Hello everyone. Hey guys, how are you all? Am I audible? Please once check and do let me know if everything is fine or not. Check it once and do let me know whether everything is fine or not. I'm more concerned about the voice. Let me know. It's fine? Everything is fine or not? Okay. Okay. I'm more concerned about the voice. So basically, let me tell you that what we are there for today. We have started a chemistry score booster series. Basically, your all aim is how to get marks. Okay, you all want to get good marks. So basically, from the chemistry section only, you will be getting 30 questions, and out of all those 30 questions, you have to at least do 25 questions. So out of 30, if you have to do 25 questions, so if you do them well, you will be able to get at least 100 marks. Okay, so 100 marks only from the chemistry, and by over 180 or 200 marks there would be a cutoff that will go on. Okay, so basically chemistry can, one subject, it can itself give you a very good percentile. So definitely you will be working for the physics and maths also, as you already know that over the JEE English we do have the other educators also, like Anshul Singles and the Mithil Chancer, who was taking your maths and physics. Definitely you will be going to score good number. But here, what to focus, what to do, guys, for the chemistry subject, previous year questions are very important. So here I have started with the topic wise series. Okay, in a month we are going to target 10 topics. I have given the schedule which you can find in the community section. ठीक है, आपको community में मिल जाएगा कि वो 10 कौन से topics हैं, over which I will be taking the previous year questions and the most expected questions. So for today I am going to start with the GOC. This is our very first topic. And here I would let you know guys that I have taken so many number of questions. Okay, and all these questions you people have to answer. Okay, if you would see, many of them are the previous year questions and many of them are the most important questions, so all of them like mixed together. Okay, so wherever you are having the previous year question, the year will be mentioned over that. So in total you can see that there are 68 questions which I am having for you for today. Okay, so this GOC will include the naming, the isomerism, okay, the naming, the isomerism, the carbocation carbonyl stability, the nucleophilicity, or everything that comes in GOC. Okay, so are you interested and are you ready to go with the session? Hanji. Okay, so basically टॉपिक वाइज है ना, टॉपिक वाइज टारगेट करते हैं सो दैट वी विल एंजॉय द सेशंस. सो हियर दिस इज अ वेरी फर्स्ट क्वेश्चन फॉर यू ऑल. पहला क्वेश्चन तुम लोगों के लिए. चलो, the hydrocarbon with 7 carbon atoms containing a neopentyl and a vinyl group. यानी कि क्वेश्चन कह रहा है कि which hydrocarbon will be having a neopentyl as well as a vinyl group, it must be having a 7 carbons. So is this having a 7 carbons? Is this having a 7 carbons? Find it. Is this having a 7 carbons or is this having a 7 carbons? Okay, 7 carbons with a neopentyl and a vinyl group. Any answer? Neopentyl and a vinyl group. If you will see here in the case, this is going to be if I draw like this. Now which group is this? This is neopentyl. How neo? It is 4 degree. 1, 2, 3, 4, 4 degree. That's why this is neopentyl. There are total 5 carbons. Carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. 5 carbons, and this is your vinylic group. So what is the right answer, guys? The right answer for the question is option number C. That is, this much easy question. The another question, the nitrogen which does not contribute to the basicity of the for the compound is, means which nitrogen does not contribute to the basicity. Which nitrogen will not contribute? Find it. There are nitrogen number 1, nitrogen number 1, nitrogen number 3, nitrogen number 9, nitrogen number 7. So we have 4 nitrogens, out of which nitrogen which will not contribute for the basicity. What is the right answer? Guys, you know, if over the nitrogen, if we have the localized lone pair, then it will contribute to basicity. And if we have the delocalized lone pair, means the lone pair is not available. If we have delocalized lone pair, then it will not be basic. Okay, so ultimately in this question you have to find over the nitrogen which nitrogen we are having the lone pair which is delocalized, that is N9. So here we can see that this lone pair is undergoing delocalization. So ultimately this nitrogen is not basic. The question is asking does not contribute for the basicity. Answer is option number B. Is it clear? Another question, the absolute configuration of this molecule. So basically you have to tell the configuration. So when you have to tell the configuration, this is a molecule where 2 and 3 is given. So basically first you have to do the numbering. When you do the numbering, you all know that this is the carboxylic group, the highest priority group. So the carbon number 1 will be this will be the carbon number 2, carbon number 3, and this will be the carbon number 4. Okay, so over this particular carbon, what is the configuration? Over this particular carbon, what is the configuration? Find it. If you see over this particular carbon, here we have a OH, this is again a carbon, this is the hydrogen, and here we are having the carboxylic acid. So I can say that here I am having 3 oxygen atoms. These are known as the phantom atoms. And here over this carbon, if you would see, we have hydrogen, we have chlorine, and we have a carbon, right? So out of this, which will be having more priority, to which you will be giving more priority? As you all know, the priority number 1 will be given to this part, because here we have the oxygen having the highest atomic number. Now out of this oxygen and out of this chlorine, who is having more atomic number? Guys, chlorine is having more atomic number. Doesn't matter, here we have 3 oxygens, but the chlorine is having more atomic number. Considering priority number 2 will be given to this, priority 3 will be given to this, priority 4 will be given to this. Here the hydrogen is above the plane. So basically we have to do the rotation. So when we will be doing the rotation, we will keep the one bond fixed and then the other bonds will get rotated. So ultimately what you will be getting, the priority number 3, I am keeping it fixed and the other bonds are getting rotated. So I can say that here my aim is to bring 4 below the plane. So 4 will come this side. Here the 2 will go, here the 1 will go. So when you will see the configuration, what is it is. So keeping the 4th group below the plane, keeping this below the plane, we can say that we have 1, 2, 3, that is anti-clockwise rotation. This is S. So 2S. So we can say that in our answer it has to be 2S. Now look over the 3rd carbon. Over the carbon number 3rd, we have a chlorine. We have a carbon with the 3 hydrogen atoms, and here we have hydrogen, and here we have a carbon with which is being attached with hydrogen. My pen is like irritating me. Oxygen and the carbon. Now who will be having more priority? Of course, this is the priority 1. This will be the priority 2, priority 3 and the priority 4. Again we have to do the rotation. We have to bring the hydrogen below the plane. Let's keep this as fixed. So keeping this fixed, this 2 will remain there. The 4th will come down the plane. Here the 3rd will go. Here the 3rd will go and 1 will go this side. So if you will see the rotation, this is 1, 2, 3, 4. Keeping the 4th group below the plane, the rotation is clockwise. So this is R. So ultimately my answer will be 2S and 3R. The right answer is option number B. Is it clear? Getting, guys? Okay, I think yellow color is better now. Okay, I will be keeping yellow color, not red. Thank you for telling. Okay, so the right answer is option number B. You got it now? Why the chlorine will be getting more priority irrespective of the oxygen? Because the chlorine, because here we have to look for the atomic number, not the atomic weight. We have to look for the atomic number. Okay, that's the reason. Which of the following molecule is least resonance stabilized? Least resonance stabilized. What is the answer? Who will be least resonance stabilized? Mark your answer. Option number B. Absolutely. Why? See, here we have a complete resonance. Complete resonance. But when you will see the option number B, what you have to focus? See, here we have a double bond O. Definitely we will make it O negative and this will be positive. Then this is a pi bond, this is a pi bond and this is this. So when you will see the delocalization, this bond will delocalize here, this bond will delocalize here, but this is planar? No, this is not planar. This is sp3 hybridized carbon atom. So this is not aromatic. So this molecule is not aromatic. But if you will see the other molecule, they all are aromatic. They all will be having a resonance. This is aromatic. Okay. This is also aromatic. This is a benzene ring. Aromatic. And if you will see here also we have the lone pair of electron, and these lone pair of electron will undergo delocalization, and this is also having the 6 pi electron, and so therefore this is aromatic. So all are resonance stabilized, all are aromatic, but not option number B, because here the carbon is not planar. A mixture containing the following 4 compounds is extracted with 1 molar HCl. The compound that goes to aqueous layer is, how you will solve this question? It's very interesting. If you have a mixture containing the 4 compounds, these are your 4 compounds, and this has to be extracted with 1 molar HCl. So 1 molar HCl is water. This is an acid. So I want to extract it with acid. The compound that goes to the aqueous layer, guys, you know, when you have an acid, you will be treating it with a base. There you will be getting the formation of a salt plus water. So ultimately you will be getting it in the presence of water. It will go into the aqueous layer. So if you are extracting something with the acid, you have to focus out of all these 4, which is a strong base. Whosoever will be a strong base will try to react with the HCl, form a salt, and will get extracted from the aqueous layer. Absolutely, Anmol. Tell me then, which is going to be the strong base out of all this? If you look for the basicity of the sulfur, if you look for the basicity of this oxygen, if you look for the basicity of this oxygen, and if you will look for the basicity of this nitrogen, nitrogen is most basic, because here if I have to compare between the nitrogen, oxygen, sulfur, okay, what I can say that nitrogen is less electronegative. So because here when we are moving from left to right, nitrogen is less electronegative. So that's why it is more basic. It is more basic than the oxygen. And as you go down the group, so here the electronegativity factor will apply. And here as you go down the group, the size of the atom increases. So the bond with the H will become unstable. Okay. So the bond strength decreases. So it will not be a good proton acceptor. The sulfur is not a good proton acceptor. So it's a poor base. Got it? So that's the reason. So top to bottom, left to right, electronegativity factor works. Top to bottom, size factor works. Okay, top to left to right, we have to see which is a good donor. We have to see who is a good donor, who is a less electronegative. Whosoever is less electronegative is going to be a good base. But here top to bottom, we have to see who will form a strong bond. So we know that OH bond will be stronger. This bond will be stronger as compared to that of the SH bond. Okay, this will be weaker. Okay, because the bond strength decreases. So because of all such reasons, this second, we can say that B is the right answer, isn't it? Hi Shreya, Vansh. Understood, Vansh? Why sulfur is not a good base? Because as we go down the group, sulfur will not be able to accept the proton more strongly, because as the size increases, here in the case of sulfur we have 3p1s orbital and here we have 2p1s orbital. Okay, so the overlap becomes weaker. That's the reason. Another question, the IUPAC name of the following compound is the easiest question. All the questions till now are very easy. This is a question has been taken from the JEE 2017. IUPAC name of the following compound. So how to solve this? You know, when we have a ring and when we have a chain, so the portion which is having more number of carbon atoms will be considered as a root word. So here you can see that we have 1, 2, 3, 4, 5, 6. So ultimately this will be considered as a root word because here we have only 2 atoms. Okay? So this is going to be cyclohexane. Cyclohexane, 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 cyclohexane. Now how to give the numbering? Guys, here if you will give the number 1 and number 2. So the sum of locants, if you do the sum of locants, you will find that it is going to be 1 plus 1 plus 2. So ultimately 3. But if you will do the opposite of it, if you will do something like 1, 2, then it will become 1 plus 2 plus 2. That is 5. So I think this is minimum. So this is better. So ultimately what will be the name? The name of this molecule will be, this will be 1, this will be 2, this will be 3, 4, 5 and 6. Considering that, we can say that it has to be 2-ethyl 1,1-dimethyl cyclohexane. Isn't it? Because alphabetically E has to come first, then irrespective of M. So the answer is 2-ethyl 1,1-dimethyl. B. Ramesh, you people are saying C. 1-ethyl, no, we will keep 1,1-dimethyl. Sum of locants. Swapnil, don't forget about the sum of locants. Sum of locants has to be minimum, na? This is a substituted molecule. Another question, which of the following compounds is most reactive to an aqueous solution of sodium carbonate? If I am having sodium carbonate means I am having Na2CO3. So which of the following compound is most reactive? Who will react at the fastest rate with the sodium carbonate? Tell me. Aqueous solution of sodium carbonate. So if it's aqueous solution I am talking about, it will result into the formation of H2. What it will form? H2CO3 and NaOH. I will be taking 2 moles of this. This will result into the formation of H2CO3 plus NaOH. Okay, that is carbonic acid plus NaOH. 2 moles of NaOH. 2 moles of NaOH I will be getting. I will be getting 2 moles of NaOH. And here I will be getting H2CO3. Okay. Now considering that, which of the following compound is most reactive to an aqueous solution of sodium carbonate? So which compound will be most reactive? Can you tell? You know, NaOH is a very strong base. So ultimately this solution is going to be basic in nature. So if NaOH is a strong base, it will try to pull the H positive. है ना? It will try to pull the H positive. That is the acidic hydrogen. If I would say here I am having the acidic hydrogen. This is my OH negative. This will pull the H positive. So ultimately what I will be getting? Here I will be getting the formation of this and this. This as a species. Here if I am having the NaOH, a basic medium, it will try to pull the electron. Of course, from this carbon it will try to pull, because this is the only acidic hydrogen. Then what it will result into the formation of, if there will be a loss of H positive from here, you will be getting this as the conjugate base. From here, if you are treating it with the base, then it will result into the formation of base can produce the acidic hydrogen. You can get negative or negative. Okay, this could be the conjugate base. This is also the acidic hydrogen. This can also be the conjugate base. Both possibilities are there. Here in the case of D, if I do the same, then I will be getting this as negative and this as negative. So which is most reactive? We all know that thickness of pen, but the thickness of pen cannot be increased. There is no such way. Can I do anything? No such way, bache. Ganga, isn't it visible? If possible, you please try to attend the lecture through the laptop. Absolutely, Shubham. The question is from the aromaticity. Okay, so if this base will try to react with the acidic hydrogen, here we are getting this conjugate base, and this is more stable. Sorry, I can say that this is more stable. This is more stable. Why this is more stable conjugate base? Because this is aromatic. So ultimately, who will be most reactive? Who will react at the fastest rate? Option number C. Is this aromatic? No. This is anti-aromatic. Is this aromatic? No. If you would see, this is not aromatic. This will be not aromatic. Here we have the cyclobutane ring, which is not stable, and this is also not stable. Okay. No choice. Shreya, I think yellow color is working well. Please do let me guys which color you people are more comfortable with. So here, as per the question, you were doing the reaction of sodium carbonate. The question was saying who will be most reactive to an aqueous solution of sodium carbonate. Okay. Another question, let's move on. In the following structure, the double bond are marked as 1, 2, 3 and 4. Okay. So this is a double bond. This is a double bond, this is a double bond, this is a double bond. There are 4 double bonds. Geometrical isomerism is not possible at site where the geometrical isomerism is not possible. This is the question that you have to answer. Tell me. Okay, thank you. I will be choosing yellow only. Dhramesh, tell me, what is the right answer? Geometrical isomerism is not possible for water. Geometrical isomerism is not possible for B. First, absolutely first, because these two groups are same. Because the reason is these two groups are same. So when these two groups are same, this cannot show the geometrical isomerism. Absolutely right. What else? B, only B. Same methyl. Acha, any other possibility? Any other possibility? Ma'am, about 2. Second is geometrical isomerism you can show, because here we can give the priority order, no Anshul? We can give the priority order, and depending on that we can answer it. Because here the hydrogen will be having low priority, this will be having high priority. We can find out E and Z there. Okay. Now here this will be having more priority, this will be having low priority. So ultimately this is a opposite priorities. The same priorities are on the opposite side. So this will become E. Okay, so yeah, the right answer is option number B. That is first only. Very good. Another question. Which of the following compounds will show the highest dipole moment? Out of all this, which will show the highest dipole moment? Means polarity. Which will be having the highest polarity? Give your answer. So my suggestion, whenever you are looking for the polarity, break this bond. So when you will break this bond, you will find that it will become O negative and positive. If you will break this bond, you will be getting O negative and positive. This as a pi bond. For this molecule as well, then find out which is going to be more polar. Okay, which is the highly polar molecule. Tell me the answer. Option number 1, 2, 3, 4. This is 1, this is 2, this is 3, this is 4. So this much I did for you, and your answer is very good, Vansh. The right answer is option 1. Why the correct answer is option A? Because here it is clearly visible to us that first of all, this is a very stable molecule, have 2 pi electrons, and hence it is aromatic. Okay, and here the movement of electron is in this direction. Okay, so the positive and negative oxygen, and here this is highest dipole moment, and this is also a nucleophile. So who will also give its electron after delocalization? Because of the resonance, the electrons are also moving in this direction. So the vector sum is in the same direction. So ultimately the dipole moment increases. Okay, that's the reason. Okay, because of the aromaticity there will be delocalization, and delocalization will be towards the positive charge. That's the main reason. Okay, and here it is in the opposite direction. Ultimately it will cancel with each other. This will be having the zero dipole moment. So if you are talking about the maximum, definitely the maximum in is 1. Another question for you all. Among the following compounds, the increasing order of their basic strength is, which is going to be having the strongest basic in nature, which is strongly basic? Figure it out. Do the question. Which will be strongly basic? Who is having the localized pair of electron and is going to be most basic? You have to give your order. Who is going to be the least basic? B or C? We have the nitrogen atom. Very good. Agree. The right answer is option number C. Why the right answer is option number C? Guys, here you can see that if we look for this molecule, here it is aromatic. So here the lone pair is a part of the aromaticity. This is more stable. So very resonance stabilized. Can this be a base? No, this can never be a base. Okay, so second is going to be the least basic. We can say that second. Now the point is, here also we have the nitrogen and its lone pair is undergoing delocalization over the benzene ring. But yeah, it is not a part of aromaticity, it is just a part of resonance. And here it is a part of aromaticity. So that's how this is more stable and this is less stable. Okay, so relatively 2 or 1 is more basic. Okay, we agree. Then what about this third and fourth? If you will look for the third and fourth, the increasing order, here over we can see there is nothing will be given to you. So ultimately, if the solvent is not given to you, then what you can say? I can simply say that rather than C, I could say Guys, see, if you will apply the electron density factor, you will say that this is going to be more basic. But if you apply, you forms its conjugate acid, that is NH3 positive, and this NH3 positive is going to be more stable because of the hydrogen bonding. So it totally depends that what concept you have applied. Okay, so if your concept is of the if it is in the aqueous medium, then definitely the fourth is going to be the more basic, because it will get more stabilized because of the more hydrogen bonding. Okay, so it depends upon the medium. So here in this question there was an ambiguity whether the option number C will be right or option number D will be right. I suggest my students, if you get any such kind of question, always apply the Bronsted based definition. Always apply the Bronsted based definition and see the basicity in the case of see the basicity in the presence of water only, if nothing is being given to you. So that's how I would say the right answer has to be D, not C. Is it clear? Got it? The increasing order of basicity of the following compound is. Here again we have a question that came in JEE Mains 2018. The question is again talking about the basic strength of the amine. So which nitrogen lone pair is going to be more basic? Here we have two lone pairs, this nitrogen and this nitrogen. Here we have this. So what is the basicity? What is the strength of basic character? Options are basically, this is B, I am writing it again, this is C, and this is D. Now mark your answer. Done? C. Okay, let me talk about this question, guys. Here you know we have a localized pair of electron, there is no resonance. Okay, so this is a localized pair of electron. Here we have the localized pair of electron. Okay, and here we can see some of the minus I effect of this pi bond. Okay, if you will see, this is also the localized pair of electron. But here this nitrogen is basically having the sp2 hybridized character, and here this nitrogen is sp3 hybridized character. So as the percentage of S character decreases, the electronegativity decreases and it becomes more basic. So if you ask me about A and B, I will say that bachche, your A is going to be more basic than the B. If I have to compare, I will say that A is going to be more basic than the B, because here this is sp3 hybridized nitrogen and this is the sp2 hybridized nitrogen. So as the S character increases, the electronegativity increases and the basicity decreases. Now here if you would see, this nitrogen lone pair is in resonance. So definitely this is not basic. But here this nitrogen is more basic. Why? Even this nitrogen is increasing the electron density over this nitrogen. So basically this nitrogen is basic because this has the localized pair of electron. So out of C and B, I will say that C is more basic than B. So this is my call. This is my call. Okay, now if you have to compare with the C, with the option number D. With the option number D, here we have the nitrogen and here we are having 2 plus I effect. This is also increasing the electron density over the nitrogen and it is also increasing the electron density over the nitrogen. So if you will see the option number A or option number D, I will say that option number D is going to be more basic as compared to that of the option number A. Why? Because in the D we are having more plus I effect rather than more electron density is increasing, but here we can say that there is the minus I effect of this double bond. So ultimately what do you come to a conclusion? A or C, which is going to be most basic? I would say C is going to be the most basic. C is the most basic, localized, and even this nitrogen is also increasing the electron density over this. So when this species accepts the H positive, you know what will happen? When this accepts the H positive, this will become NH2 positive. and it will undergo resonance stabilization. This will go here and this will go here. Ultimately, we will be getting NH2, and this will be a double bond, and this will become NH2 pair. We will be having a positive. So here the positive charge is getting delocalized. So ultimately here I am having plus 1 by 2, here I am having plus 1 by 2. So this is most stable, okay, most stable, because lower the charge over the nitrogen, more will be the stability. So ultimately we can say that C is going to be most basic. Now just compare between B and D. So what is your call between B and D? B is this, D is this. Here nitrogen is sp2, here nitrogen is sp3. So my call is the sp3 hybridized nitrogen is going to be more basic. Okay, D is more basic. D is more basic. So D is more basic as compared to B. So the right answer is option number C. So C, then D, then A, and then B. Clear? This is it. Hanji, C is basically a type of a guanidine, amidine kind of structures, right? It is amidine. Another question. The nitrogen which does not contribute do the question. The nitrogen which does not contribute to the basicity for the compound is, which nitrogen will not? We have done the same question earlier as well. I think it's a repeat, and here the answer is also given. So let's forget about it. Absolutely. This is the answer. Here we have not contribute because it is undergoing delocalization. That's the reason. Another question. The most polar compound among the following is? The most polar compound among the following is? You have to look for the polarity. Tell me. For 12th, I am going to start with the D and F block and coordination compounds. The coming week, I will be taking two core topics, D and F block elements and coordination compounds. So I better say over the weekend, you do prepare these two topics so that you be ready for this kind of session. Okay, Hari. B or C? What is the right answer? Out of B and C, bachche, C is the right answer. Why? Here the fluorine and the fluorine, they are in opposite direction. So here it will not be polar. The question is asking about the most polar. Definitely. So here this is the direction of polarity. This is the direction. Ultimately we will be getting the vector sum in this direction. So the dipole moment increases. But here it is in this direction. Here it is in this direction. Again the vector sum decreases. So the answer is option number C. Another question. The increasing order of pKb for the following compound will be? The question is asking the pKb increases. Now you know the pKb increases, then we can say that the Kb decreases. If I am saying that the Kb decreases, means the basic character decreases and the acidic character increases. So this is the relationship. So out of all this, which will be having the increasing order of pKb? pKb has to increase, means basic character has to decrease. So which will be least basic? And which will be most basic? There are 3 molecules. And these are the options. There are 3 molecules and these are the options. A, B, C, D. Hanji. Again, this is a guanidine kind of system. here we can see that over this molecule, this is the nitrogen, this is such a molecule. Okay, so here what is happening? We know that this nitrogen is giving its electron pair to this nitrogen. This nitrogen is also giving its electron pair to this nitrogen. Ultimately, this is most basic. This nitrogen is most basic. So ultimately, this will be forming a conjugate acid. Okay, so what will be the conjugate acid so formed? The conjugate acid so formed is going to be, this is N, this is N, this is double bond, this nitrogen will form a H positive. Ultimately this positive will form the three resonating structures, 1, 2 and 3, and if you will see all the three resonating structures, you will find that this positive charge is getting delocalized. This will go here and this will go here. Ultimately we will be getting plus 1 by 3, plus 1 by 3 and plus 1 by 3 over all the three nitrogens. Okay, so ultimately the positive charge is getting delocalized, so we can say that this second structure is most basic. So second one is most basic because here we are having plus ka 1 by 3 charge over the nitrogen. Now if you will compare between the first structure, okay, if you will compare between the first structure, then what you understand is here this nitrogen is giving its electron pair to this and this is going here. So again we are having resonance. This is the localized pair of electron. So this NH2 is forming CH double bond NH2 positive. Again this is a conjugate acid. Now we have to check its stability. Again guys, this will result into the formation of two resonating structures. It will go here and it will go here. So if you will draw the two resonating structures, this can become something like this. So ultimately here this positive charge is also getting delocalized. So if you will be forming its resonance stabilized structure, the plus 1 by 2 and 1 by 2, that is plus ka 1 by 2 we will be having a charge. Okay, and here if you will see the third structure, here we have this is NH, this is methyl and this is methyl, and here if this is accepts the H positive, we will be getting this. Here we have plus 1. So nitrogen with plus 1 by 3, nitrogen with plus 1 by 2 and the nitrogen with plus 1, which is more stable. Guys, nitrogen with lower charge is more stable than this. If it is more stable, this is most basic. This is most basic. So ultimately I can say that 2 is most basic, then the first, then the third. So ultimately if my KB is decreasing, the pKb is increasing. I can say that. Okay, so the right answer for the question is option number D. So I think this was a very interesting question. Okay, got it? The options were those who were given downside. This is again an amazing question that came in the JEE 2020 examination in the shift 1. A solution of metachloroaniline. Oh my god, amine chapter is most important. Again and again we are getting questions from the nitrogen side. A solution of metachloroaniline. Okay, those who are definitely came here to study, they will find this session helpful. Others just for time pass, okay, they will come and go. Okay, so metachloroaniline, this is aniline and here over the meta position I am having chloro. Now this is metachlorophenol, means over the same meta position I am having, and this is my phenol. Now and the metachlorobenzoic acid. Okay, if I am having the metachlorobenzoic acid, this is metachlorobenzoic acid. Okay, even I am giving you the detailed explanation so that you guys would be able to revise your concepts. The things may becomes more clear. Are you getting my point? Okay, so this is the whole reason which I want to put it here. You guys must enjoy this kind of learning. In ethyl acetate was extracted initially with a saturated solution of sodium bicarbonate. Means if I have taken them in the presence of ethyl acetate means I will be having the acetate and here there will be a substituent which is ethyl. Okay, in the presence of sodium bicarbonate to give you a fraction A. So my question is, who will react with sodium bicarbonate as the fastest rate? Sodium bicarbonate, this is an ionic compound, Na positive, HCO3 negative. So this is a base. It is a base. So who is most acidic? Because the thing which is most acidic can only react with it. Okay. So if a base will react with most acidic, so can you tell me which is most acidic? we all can see that this benzoic acid is most acidic. This is most acidic, because here if this is giving you the H positive, this results into the formation of a stable conjugate base, which is resonance stabilized over the oxygen atom itself. So ultimately this will result into the formation of a salt, that is a sodium salt of benzoic acid, COO negative, Na positive plus H2CO3. Okay, so this will be formed. So the question was saying, extracted initially with a saturated solution of sodium bicarbonate to give you a fraction A. So what will be the fraction A? Who will give you the fraction A? Of course, my benzoic acid. My benzoic acid will give me the fraction A. My answer could be D or A. So this is the approach that you have to apply. Many of the questions you will be getting from the simple acid-base mechanism. Salt formation, okay. Among those 15 questions, I have make you done approximately 4 questions of the same concept, acid-base mechanism, right? Now ultimately the leftover organic phase. So what is the leftover organic phase? This is the leftover organic phase. Was extracted with the dilute NaOH. Now we have taken dilute NaOH. Now who will react with this NaOH? Again we have to do the acid-base reaction. Out of these two, which is more acidic? If you ask me, my question will be, who is more acidic? Who is more acidic? Acidic, not basic. Guys, OH is more acidic. Why? Because negative charge is more stable over the oxygen. Ultimately, I have to form a stable conjugate base. So this negative is more stable over the phenol. So here, this will react. You will be getting the metachlorophenoxidine, sodium salt of phenoxidine plus H2O. So this is what you will be getting. Okay. Then the final organic layer was labeled as fraction C. So the fractions A and B, C contain respectively. So most probably, definitely I can say that fraction A is going to be the most acidic compound, that is the metachlorobenzoic acid. Then the B has to be metachlorophenol, which has been reacted with the NaOH, and then the left part, which is an organic layer, is chloroaniline. Okay, so ultimately on the basic of the acidic character, most acidic, less acidic, and this is least acidic. Least acidic. Got it? Another question. The number of chiral carbons in chloramphenicol is, oh my god. So chloramphenicol, do you know what type of structure is this? Guys, you know these kind of molecules you basically learn in the chapter chemistry in everyday life. Okay, chemistry in everyday life, which is the most underrated chapter. But I would say many of the questions comes from this particular part. At least to do such questions, you just have to find out the number of chiral carbons. So I can help you for that. Basically I have prepared this particular file for you and I can show you. Here the question was chloramphenicol, number of chiral carbons in chloramphenicol. So here I have all the structures of such molecules. So this is the structure of chloramphenicol. Let me show you a slideshow. Yeah, so this is the structure of chloramphenicol. So if you have to find out the number of chiral carbons, can you find it out? This is not chiral, not chiral, not chiral. If you will see, is this chiral? Absolutely, this is chiral. Is this chiral? All the 4 groups are different. Yes, this is chiral. Is this chiral? No, there are 2 hydrogen atoms. Is this chiral? We have to talk about the chiral carbon. Okay, so no, this is not chiral. Is this chiral? No. So what is the right answer, bache, for this question? Answer is 2. Got it? So the question is very easy. We should know the structure. Okay, so here this is a file that I will share in my Telegram group. Okay, we do have a Telegram group of Unacademy JEE English channel as well. I will share the file of all those structures because you will definitely be getting the questions from this particular part. Okay, so if you will simply try to understand the structures, okay, I will also be taking one more session on the chemistry in everyday life. I will make you understand that how we can learn these structures. What are the important things that we have to focus over? See, if there we have histamine, this simply means that we have amine. So there must be the nitrogen, it must be amine in nature. Okay, so I will give you such kind of tricks to understand that what are the most important things we need to know about all such structures. Okay, so there are so many number of structures. If you are really interested to know, here in the description as well, the link of our Telegram channel is given. Please visit it so that you get all such help. I can also provide you the DPP of this particular session. Okay. So that you people can easily solve all the rest of the questions. Okay, so here the answer is 2. Another question, the correct order of stability for the following alkoxides. Now the question is about the stability. Ultimately we have to stabilize the negative charge. So in which of the structure the negative charge is most stabilized? Figure it out. If you will try to open the structure of C, what do you get it? This negative, this will go here, this will go here. Okay, and here in the case of B, so this is your structure number C. In the case of B, either this or anything else? No. And here in the case of structure number 1, just try to open the structure. Everything will be very, very clear to all of you. Nothing special in this. Will there be delocalization? No. So which is more stable? C is more stable than B than A. The right answer is option number B. Because C, we can see that there is a linear conjugation. There is a linear conjugation. But here if you will see, this is going here and this is going here. So ultimately there is a cross conjugation. Cross conjugation. This negative charge can only be go over the carbon atom and there is no delocalization. The right answer is B. Absolutely, Gagan. Very nice. So basically to know something, to learn something, you need to invest. Now again, we are having a question, number of sp2 hybridized carbon atom present in aspartame. Oh my god. The question seems to be of GOC, but they are relating your GOC with the chemistry in everyday life. Chemistry in everyday life, right? Aspartame. So what is aspartame? If you know the structure, you can find out how many sp2 hybridized carbon atoms are there. Let me show you the structure of aspartame. Then you tell me the answer. This is what I can do for you. Here I am having the structure of aspartame. Okay, find out how many sp2 hybridized carbon atoms are there. I have shown you the structure. Now the question becomes very easy. Done? How many are there? I have shown you the question. Now at least you people answer. See, if you will start learning the structures now only, okay, but the basic things of those structures, okay, then by the exam time, yeah, you can be able to do. But if you will leave it, okay, we will see after 2 or 3 months, we will see at the end, then nothing can happen. Very good, Vishal, Gagan and everybody, Arun, very nice. The right answer is 9. How? This is the sp2 hybridized. And here if you will see, this is sp2 hybridized. Is this sp2? No, this is sp2 hybridized. Yes, this is sp2, 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 sp2. So 6 are there, and here we have 1, 2 and 3. So if you know that what are the functional groups, here we have in the case of the aspartame, aspartame is having the carboxylic acid as well, aspartame is having the amide as well, and aspartame is having the what is this? This is ester as well. Okay, so remember aspartame, here we have 3 functional groups. We have acid, we have amide We have acid, we have amide, and we have ester. If you know that there are three functional groups and there is a benzene ring, if you might know about this much, you will be able to find it out. Acha, okay, I will be having this much of sp2 hybridized carbon, because in the case of carboxylic acid, absolutely this is sp2. In the case of amide, of course this is sp3, but this is sp2. And here in the case of ester, again this is sp2. 3 are they? 6 are they? It is 9. Okay, so this is the way how you can do the question. But it is easy. Aspartame. Okay, aspartame is also saying that this is acidic. This is an artificial sweetening agent. Okay, so this is all about. Chalo. So let me talk about the another question for you all. Arrange the following compound in the increasing order of COH bond length. Means the COH bond length has to increase. COH bond length has to increase. COH bond length has to increase. Matlab means this bond length has to increase. Bond length. Figure it out. You have a methanol. You have a methanol. You have a phenol. You have a phenol. Okay, and you have a para-ethoxyphenol. Para-ethoxy. Para-ethoxy means what? OC2H5. Para-ethoxyphenol. Got your answer? I think you got your answer. What is the right answer? C or D? Some of you are saying C, some of you are saying D. How to decide? But it's very clear. Methanol is going to have the highest bond length because there is no resonance. It is going to be a completely double bond. But here you will be getting a partial double bond character. So because of this partial double bond character, the bond length decreases. Okay, and here also, if you will see, here we have OC2H5 group. Okay, so here also this oxygen's lone pair is undergoing delocalization like this, like this, like this. Okay, and this is causing the minus I effector. This is having the plus M plus as well as minus I. So because of this reason, here we are also having a double bond character. So definitely they are going to be lesser in their bond length. Methanol will be higher in its bond length, okay, because there is no resonance. And if you will see the para-methoxy and the phenol, here because of this minus M effector, ultimately the bond length is like quite bigger, okay, with respect to this. Okay, because here the movement will only be in this direction. Here there is a possibility of this direction movement as well. Okay, so that's the reason. Another question. The number of chiral centers in penicillin. Oh my god. Again there is a question in JEE 2022. This was a COVID wala exam. Hai na? So the year when there was a COVID case, we were having so many questions related to the chiral centers. And then from that exam, it has become a trend. In the 2021 as well, we were having such kind of questions. So now we can't run away from all this. Chiral center in penicillin. Now let's look for what is the structure of penicillin. Are you guys interested in telling me the structure of penicillin and the chiral carbon? Question is chiral center. Let's find it out. Where is penicillin? Penicillin, where are you? I do have the structure of penicillin. I know it well. I want to show that to you guys. Where are you? There are so many compounds. Oh, I have not found penicillin. How does it happen? I think I have missed it. It was there in the slides. Might be not there. Penicillin, there it is, no? Yeah. How it could be? Okay. So here we have the structure of penicillin. Yeah, quite tough structure. But find it out. How many sp2 hybridized carbon are there? Gagan has noticed. Okay. So where we how many sp2 hybridized carbon we have counted? I have shown you the structure. This is it. Penicillin. Do. You have to find out the chiral center. Very nice, Shreya. 3. This is the chiral center. Okay. This is the chiral center. And this is the chiral center. There are 3 chiral centers. Okay. Very nice. Chalo. Let's minimize this slide. And let's come to the apna wala answer. Arrange the following bonds according to their average bond energies in the descending order. Means you have to arrange these bonds according to the average bond energy. Means which bond will be stronger, which bond will be weaker, depending on that. So which is bond is going to be the most stronger and then weaker. I think you've done this question. Very easy. Absolutely. D is the right answer. Why? Because in the carbon and fluorine, we do have 2p and 2p overlap. In the case of the carbon and chlorine, we have 2p and 3p overlap. Here we have 2p and 4p overlap. Here we have 2p and 5p overlap. Ultimately, as the overlap, the energy gap increases, the bond becomes weaker. Energy gap increases, the good overlap will not happen and the bond strength decreases. So that's how this will be having extra high bond energy. Another question, the major product of the following reaction is. So again, as per me, this is a acid-base reaction. Simple acid-base reaction. The major product of the following reaction is. Your question is something like this. You have a double bond O. This is methyl. And this has to be treated with a H3O positive. Okay. So, of course, if this is acid, any of the base will react. Now, who is a good base? Who will react? And what will form? Simple. Here, this is a pi bond. But if you will see, here we have a lone pair. So lone pair of electron is a good base. Okay. So ultimately I can say that this oxygen will pull the H positive from here. Ultimately resulting into the formation of, this is your methyl. This will become OH bond and OHP we will be getting a positive charge. Right. And then in the next step what has happened? This positive charge over the oxygen is not stable. Ultimately we will try to stabilize it. Since we will try to stabilize it, this will result into the formation of OH and this will be a positive charge. Is this a stable carbocation? Absolutely. There are 2 reasons to stabilize this. Why? The answer is this, option number D. How this is very, very stable. See, one of the reason is this is an aromatic ring. This ring is aromatic in nature. There is a complete delocalization. 2 pi electrons are there. Huckel rule is obeyed. And here, one more thing. Over the oxygen, we are having a lone pair. Here we have vacant p orbital. So because of this back bonding, this can stabilize this carbocation. Strong bond formation. Clear show nahi ho raha hai. Acha. I will try to zoom the structures. Okay. Then if this question is not clearly visible, then this definitely be not. So let us leave this question because of the poor visibility. Let us come over the question number 24. The correct order of heat of combustion for the following alkanes is, means we have dienes, okay, so which will be having the highest heat of combustion, means who will require more energy to do the combustion. More heat of combustion. Quite easy. If you will try, then it's an easy question. Means the compounds which are more stable, or what? How to do? Waiting for your answer. Absolutely right. Option number C. Why C is the right answer? Dekho, figure it out. If you are having a pi bond, this is also a pi bond, this is also a pi bond. So how to solve this question? Guys, you know this is a trans alkene, this is trans, and this is also the trans isomers. Trans alkenes, because of the minimum steric repulsion, they are more stable. Okay, so if they are more stable, they will require a large amount of energy for the combustion. Okay, so more energy, more heat of combustion will be required by A. Here one is cis and the another is trans, and here this is also cis and this is also cis. So depending on that, we will answer that the trans is going to be more stable, will be having more heat of combustion than the B, than the C. This is the reason. The increasing order of basicity for the following intermediates is no issues, Sanjay. Bache, you will learn from the class, okay? If in case it is wrong, need not to worry. Now the increasing order of basicity, who is going to be most basic? Guys, if you will see, all are C negative. All are C negative, C negative, C negative, C negative. So, but all these C negative are of different types. Here if you will see, this is a C negative which is sp3 hybridized. Here this is a carbon which is also sp3 hybridized. This is a carbon which is sp hybridized. This is a carbon which is undergoing resonance, and because of this resonance, this is said to be sp2 hybridized. When a carbon ion undergoes resonance, it becomes sp2 hybridized. Okay, and here this is a carbon which is sp hybridized. So they both are sp3. This is sp, and this is sp2. Now you have to figure it out which is going to be the strongly basic. Guys, as the S character increases, the basicity decreases. As the S character increases, the basicity decreases. You know, this is one of the things that you need to know. A, very nice, very nice. So my hint works. So as the percentage of S character increases, the basicity decreases. Okay, the basicity decreases. Here we have 50% S character. Here we have 50% S character. Here in the case sp3 we have only how much of S character we have? We have only 25% S characters, lowest S character. So it was very clear A and B are going to be more basic because of sp3, and then after comes your D, then after comes your D because it is sp2, and then after comes your C and E. Why? Because they are sp. Okay, this is the reason. Now out of A and B, we can see that which is going to be the strongest base, means here we have the electron density factor. Of course the alkylated anion is going to be more basic. Okay, so this is what we can say, that Okay, so ultimately A is going to be more than as compared to that of the B. Now of course D will come. Then after, when you have to compare between the C and E, guys, this C and E, let me tell you, here if you will see the structure of cyanide, you will find that there is a nitrogen who is having 1 2 3 4 5 electron. Over the carbon we have 1 2 1 2 3 4 electron. Okay, now here this nitrogen which is having 5 electron shares 1 electron with the carbon, ultimately becoming 6 electron species. Now again this nitrogen has to share 2 more electrons this nitrogen needs. So ultimately what this nitrogen can do, and with respect to this we have Cn negative. So who will carry this negative charge? Who can carry this negative charge? Figure it out. Nitrogen, being an electronegative atom, can carry this negative charge. So this means that ultimately if nitrogen carries a negative charge, we can say that there will be the addition of 1 more electron. Ultimately 5 electrons, because of the negative charge we have 1 more electron. 6, 2 electron this need. So it will ask carbon, you please give me 1 more electron. Okay, so here the octet of nitrogen is complete. When you will see carbon, here the carbon is 1 2 3 4 5 6. So ultimately 6 electrons they are getting, and there we will be having a coordinate bond. So nitrogen is forming a coordinate bond over the carbon. So the structure is something like this, this as a negative charge, and over the nitrogen also we have a lone pair of electron. So if you will see the Cn negative, you know this is a diode system. This is a diode system, and this is a very stable structure. Okay, this is very stable structure. If you will see the HCN, in the case of HCN we just follow the diode system, and it is a poorest base. It is very acidic. If you are talking about, yeah, its basicity decreases, because ultimately here over a triple bond we have this negative charge is basically over the nitrogen, and if you will see here we have the nitrogen which will also be causing the minus I effect, and here we have the carbon. Okay, so relatively this is going to be more basic than this. So E is going to be more basic than the C. Chaliye, now let's move ahead with the another question. The number of sp2 hybrid orbitals in molecule of benzene is? How many sp2 hybrid orbital? Please focus over the question. How many sp2 hybrid orbital in molecule of benzene is? This could be an integer type question as well. I am waiting for your answer. Shreya, Dhramesh, Gagan, I'm strongly expecting this answer from you guys. See, I knew you people will do wrong. Is this sp2 hybrid carbon? Is this question asking about the carbon? Please read the question carefully. No, the question is asking sp2 hybrid orbital. So if you will draw the structure of benzene, you know what has happened? You know what has happened? Here we have sp2 hybridized. They all are sp2 hybridized now. They all are sp2 hybridized. Got it? These are the hybrid orbitals. So every carbon is having how many hybrid orbitals? We have 6 carbons, and every carbon is having 3 hybrid orbitals. So total 18 is the answer. Okay, and how benzene is having a pi bond formation? Because along with this sp2 hybridization there is a head-head overlap. Because of this head-head overlap we are having a sigma bond, but at the same time here we have a p orbital as well, and this p orbital shows this kind of delocalization. Okay, but this pi bond shows this kind of sidewise overlap. So because of this reason we do have a pi bond as well. Okay, now here also I could be having a p orbital and a p orbital, so they can overlap this side, and so therefore we can have a pi bond here. Got it? Answer is 18. Another question: which of the following has the shortest CCl bond? Which of the following has the shortest CCl bond? Whenever there is a question of bond length, bond order, or something, you have to think of resonance, right? Dan? Okay. Pulling the electron density. So pulling the electron density, okay. Pulling the electron density. CCl bond length now. Oxygen can also do the delocalization this way. Okay. Bond length has to decrease. No, it's not about highest resonating structure. It's not about highest resonating structures or the more number of resonating structures. It's just about that the strongest the electron pulling group is. Okay, so more will be the resonance. O negative. This is going to be the very stable structure because the negative charge is going to be very stable over the oxygen atom. So ultimately here over the carbon chlorine bond we will be having a double bond character. Okay, because ultimately the negative charge very stable. So this is a stable structure. So this is the stable resonating structure. If I draw the resonating structures, this is going to be the most stable resonating structure. That's the reason. Okay. This kind of stability we are not getting in other structures. That's why the answer is option number D. Which polymer has chiral monomers? Basically, you have to draw the structure of Bona and neoprene nylon 66 PHBB. Again, this is basically a question from polymer and biomolecules. This is one of the course which I am going to start over the Unacademy's Plus platform. From 17th of November, we will start with polymers and biomolecules. Okay, and so this is polymer plus GOC because the chirality we learn in GOC and these are the molecules of polymers. So ultimately this is how the question gets mixed. Now here the decreasing order. The question is about the decreasing order of basicity. Decreasing order of basicity. Who will tell me the right answer? See, from the examination point of view, amines, the acidic character, the basic character is the most important thing. No. There is a cross conjugation. आपने पूछा ना मैम पिछले वाले क्वेश्चन में देयर विल बी अ नेगेटिव चार्ज ऑन द ऑक्सीजन एटम इन द ऑप्शन नंबर सी राइट no बच्चे because there we have two types of delocalization. Oxygen lone pair can also give the electron pair rather than pulling. It will try to give because it is also having a lone pair of electron. No, decreasing order of basicity. Who is most basic here and who is least basic? We have already done this kind of question. Answer is B. Absolutely. Fourth is more basic because here we have the plus I effect and here this lone pair is sp2 hybridized. Rest, this lone pair is sp2 sp3, and this nitrogen lone pair is also sp2 hybridized, and it is even aromatic in nature. If even it is aromatic in nature, and this nitrogen lone pair is also, because it is in resonance, so yeah, we can say that this is also sp2, but still more available. sp2 sp2 sp2, reason being here the nitrogen still we can say that there we are, here we are having the plus m effect of this benzene. So what is the right answer? The second is going to be the least basic because of aromaticity, because its lone pair is stabilized by aromatic nature. That's how. And here fourth is going to be the most basic, because this is simply sp3 hybridized localized pair of electron. And if you will compare between the third and absolutely one, here this nitrogen is sp2 hybridized, but its lone pair is available. It is localized pair of electron. Are you getting? This is localized pair, while this is delocalized pair. That's why third is more basic than the first. Absolutely. I hope you got the answer. Another question for you all is question number 30. Arrange the following labeled hydrogens in the decreasing order of their acidity. Now the question is about the acidic strength. Do this. Only 11 are correct. Okay, koi nahi, take it as your learning time. Okay, I think this might be the very first time when you were doing the previous year questions, or you were solving the questions wholeheartedly, Gagan. है ना? If you will keep doing all this, if you will make it a practice, then definitely next time you will be able to at least correct 20 out of 30. Arrange the following labeled hydrogens in the decreasing order of their acidic strength. Now decreasing order of their acidic strength. So here I may tell you guys, this is bonded with O, this is also bonded with O, this is also bonded with O, and this is bonded with carbon. Okay, so this is the difference. So which is going to be more acidic, carbon wala or oxygen wala? Okay, means OH is more acidic or a triple bonded carbon hydrogen is more acidic. Guys, here this is more acidic. Why this is more acidic? Because the negative charge will get more stabilized over the oxygen. Rather than, yeah, this carbon is also sp hybridized, because of the sp hybridization it is becoming electronegative, but relative to oxygen, yeah, it is less stable. Okay, so considering that, OH wala groups are going to be more acidic. I can say that A has to be least acidic. A has to be least acidic. Now out of these two options, 2 and 3, figure it out. What will be the right answer? Because this is a less stable conjugate base. If this gives you the H positive, here we are having O negative, and this O negative is again resonance stabilized. This is also O negative, again resonance stabilized. But here if you will see, we will be getting the O negative, which is stabilized over the oxygen and oxygen atom. So definitely COO negative is very stabilized rather than O negative with the benzene ring. Okay, so I can say that the carboxylate, the B1 is more acidic. B1, that is this. Okay, how to compare between the C and D? C and D you can compare depending upon the NO2 group. NO2 will be causing the minus I effect. So as minus M or minus I effect. So if you will see, here it is at the para position. So here this negative charge will go this side, this will go this side, this will go this side. Ultimately NO2 will pull the electron. So because here over the C we are having the minus M effect, that's why C is more acidic than the D. Absolutely. Another question, the IUPAC name for the following compound is? Guys, what do you say? You want to continue with this session, or you want that I may take one more session on the same? I can divide this GOC session into two parts. Okay, the 30 questions, approximately 31 questions, let us do today, and the rest of the question I will be taking either tomorrow or day after tomorrow. What say? We can also do one of the thing. I will share this file with you. You solve every question, and in the upcoming session, I will be discussing the doubts of yours. That can also be a better way. You can easily, aram say, you can read the question and then come up with your answers. One more? Definitely I will be taking one more. Don't worry about it. What do you say? What is the answer? Which is the highest priority functional group? Whenever we have a molecule with multiple functional groups, we have to take that particular root word which consists of both the functional groups. Right? So here the numbering will be done in such a way. This is number 1, this is number 2, this is number 3, number 4, number 5 and number 6. You know that? You know that? Now solve it. So this is your highest priority group, that is 1 oic acid, 1 oic acid, 1 oic acid, then 3 enoic acid, hex, 3 enoic acid, hex, 3 enoic acid. This cannot be enol, this cannot be enol. This is 2 methyl or 6 oxo. What it would be? 2. Here we are having 2,5 dimethyl. Yes, we have 2 and we have 2,5 dimethyl. Absolutely. We have 2,5 dimethyl 6 oxo. This is a secondary group. This is a low priority functional group. So this will undergo in prefix. This will go in prefix. And in prefix we can call it oxo. Okay. So yeah, B is the right answer. Clear to everyone? Carboxylic is the most dominating group, has more priority. That's why we started numbering from the carboxylic acid. Now here in the question, this structure is given to you. You have to find out the number of chiral carbons present in the given molecule. Now the question becomes easy, right? The structure is given, figure out the number of chiral carbon. Is this chiral? Absolutely. One chiral. Is this chiral? No, 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 no. This is chiral. Yes. Is this chiral? 1, 2, 3, 4. Absolutely. So 1, 2, 3. After 3, this is also the chiral group. This is also the chiral atom. Okay. How many are there? 1, 2, 3, 4, 5. Any other chiral atom are there? Any other is present? Tanmay, it's 5, bache. They are 5 in number. 1, 2, 3, 4, 5. Okay, 5 is the answer. No, Gagan, it's not 6. Please don't confuse. This is not carbon. This is a complete bond. Okay, this is not a carbon here. Don't misunderstood by this. This is a kind of a bridge. Answer is 5. Which one of the following compounds possesses the most acidic hydrogen? Which is having the most acidic hydrogen? Find it out. Is this the most acidic hydrogen? Is this the most acidic hydrogen? This is the most acidic, or this is the most acidic? I think you got your answer. This is OMe. Where, bache? You said, ma'am, how can the carbon above nitrogen be chiral? Be chiral, it has 2 ethyl groups attached. No, it is not 2 ethyl group. This is bonded to the nitrogen. Are you getting it? This is not ethyl. This is bonded with this nitrogen. This is a cyclic structure. This is a 6-membered ring. If you will open the ring, this is something like this. Here we have the nitrogen. They can also show this ring like this can also be shown like this. This is that. Understood now? Okay. So this part is not actually ethyl. This is a different ring and this is a different ring. And over this, there is a kind of bridge, which let me show you how it is like. This, this and this. So this is a complete one bond. So if you will see the chirality, this is a chiral atom. All the 4 groups are different. One of them is going to be the hydrogen. And then after this is also chiral, because this part is different, this part is different, this part is also different. Okay. And others are not chiral. Now understood? Now do the question number 33. Which of the following molecule is going to be most acidic? Answer is C, because this is the most stable conjugate base. Here we have a cyanide HCN. Always remember, this conjugate base is very, very stable. Okay, the answer is C, not B. Over the B, you are having, of course, you can say that here we are having 3 groups, but still, if you will look for the most acidic hydrogen, they are stabilized. But again, here, because of the presence of this O group, we are having the electron density will increase. Okay. But here we will be getting this kind of resonance stabilization. C is more acidic. C is more acidic. If you have to give the order, then what is the right answer? If you have to give the order, then what would be the right answer? Can you mark it? If you have to give the order. This hydrogen is also bonded to carbon, which is sp3 hybridized. This hydrogen is bonded to the carbon, which is sp hybridized. This hydrogen is bonded to the carbon, which is sp3 hybridized. This is also bonded to the carbon, which is sp3 hybridized. Now, which hydrogen is most acidic? Here you have a resonance, here you have a resonance, here you have a resonance. Here there is no resonance. You will be getting a negative charge only over the carbon. So if you will see the order, C is going to be more acidic, then B, then D, then A. Absolutely, Shreya. Right answer. Another question. Can you do this? Consider the following molecules and statements related to them. This question was also came in September wala exam, that is in 2020 shift 1. Hi Night. So the question says that if you have such a molecule, how will you answer the question? This and this. B is more likely to be crystalline than A. Will B be more likely to be crystalline? Will it form the crystal structure? Think about it. B has higher boiling point than as compared to that of the A. B will be having higher boiling point and B dissolves more readily than A in water. How to answer this question? See, in the case of A, if you will open the structure, you will find that this is O, this is carboxylic acid O, and here we will be having intramolecular hydrogen bonding. Intramolecular hydrogen bonding, right? So intramolecular hydrogen bonding, will it form aggregate? No, this will not form aggregate. है ना? No aggregation. No aggregation. Okay, so molecular weight decreases. Molecular weight remain the same or it decreases. So ultimately, will the boiling point increases? No, the boiling point decreases. But here, if you will see the option number B, in the option number B, what can happen? Here we are having the carboxylic acid. and this is the OH. So ultimately what can happen is we can have one more molecule. We can have one more molecule of the same type, and let's say here we have the alcohol. This can form the hydrogen bonding. Okay, if you will see the structure, this is OH. Okay, this can also show the hydrogen bonding. OH bond can form the hydrogen bonding. So ultimately, because of this hydrogen bonding, there could be two possibilities. First of all, there could be a crystal structure. Yeah, this can result into the formation of crystal structure because of the intermolecular hydrogen bonding. Intermolecular hydrogen bonding. What will happen? More number of molecules will combine together. More number of molecules will combine together. Aggregation will happen. Ultimately, molecular weight increases. Molecular weight increases, the boiling point increases. So boiling point increases, the crystal structure this will form, and even this can also interact with water. If you have H2O, with H2O also this can show the hydrogen bonding. So this will not show the hydrogen bonding with the water. Why? Because it is intramolecular. It is undergoing chelate formation. It results into the formation of chelate. But here this can show the hydrogen bonding. Ultimately it is soluble in water as well. So here we can say that B is more likely to be crystalline. Absolutely. B has more boiling point than A. Yes, because the aggregation increases, the boiling point increases. B dissolves more readily than A in water. Yes, B can have the hydrogen bonding with water. So what is the right answer? B. No. Actually, for this question, you got the bonus marks. Pupil got the bonus marks while answering B. But in actually, the right answer is A, B and C, all true. All true. Okay. So the question, what is aggregation? What is aggregation? Aggregation means accumulation. Accumulation means more number of molecules will combine together, gathered together. Okay, they will be crowding. Ultimately, the molecular weight increases, and if the molecular weight increases, then the boiling point increases. There will be more interaction. No, A compound cannot show. Why A compound cannot show the intra and intermolecular both the hydrogen bonding? Because there is a formation of a stable ring. Because this is resulting into the formation of a stable ring, 6-member ring, which is known as a chelate. So ultimately this will become very stable that it will be very difficult for us to break it. Even this cannot be broken, and so therefore this cannot even react with the water, and this will not be water soluble. Got it? So last question for today. There is a question, how many chiral centers are present in threonine? So ultimately, oh my god, here I have given you the answer as well. Something wrong. Okay, no issues. So yeah, there is a mistake with few of the questions. The answers are given. It's fine guys, no issues. So I think I would end the session here today. Okay, I will be taking the second part of the GOC. Most probably tomorrow or day after tomorrow I will update you on the same. Okay, and then this is a file which I am giving you in homework. Okay, I am not giving you the answer key of all those questions. You please try them out. I will also be giving you the file of the structures of molecules. You draw the structure, find out every answer, and be ready for my tomorrow's session. Got it? ठीक है? Tomorrow I will see you. Clear everybody? Okay, and whatsoever your doubts would be, they will get clear in a better way. No, basically the boiling point increases when the interaction increases. Are you getting my point? The boiling point increases when the interaction increases, when the molecular weight increases, when the van der Waals interaction increases. Okay, so as the number of molecules gets more and more attached, ultimately you please always remember intermolecular hydrogen bonding results into the formation of a bigger structure, big molecule. Okay, if there will be a big molecule, the boiling point increases. Why the water is having a high boiling point, that is 100 degrees Celsius? Because water is also having a formation, has a tendency to form the intermolecular hydrogen bonding. Because of those intermolecular hydrogen bonding, many H2 molecules combine together, they form an aggregate, they becomes a large molecule, and so therefore the boiling point increases. Got it? You can get the file in the Telegram group of our Unacademy JE English channel. Okay, you do also join me, because I'm also going to come up with the plus courses on Unacademy on the topics like polymers, biomolecules. Okay, so you join me there. This is it, I would say. And if you really enjoyed today's session, please hit like. That would be amazing to get from you guys. For all such efforts, for all such preparation which we are coming up for you, we are just expecting a like and a share from your side. Thank you so much. I hope to see you tomorrow. Right now it's very difficult for me to speak more, so see you later. We have also started with our 5 a.m. club, so if you want to be a part of that 5 a.m. club, you can join me tomorrow morning. Okay, see you all there. And whatever the doubts, whatever you want to say, you please leave it in the comment section. I will definitely appreciate your comments. Okay, so do let